everyone. So I decided to work on a little project and I thought I'd just document my progress on it. So I've decided to spend a few hours each night after work working on this little project. As you might know, I found sort of a treasure trove, a time capsule if you will, of some games that I wrote a few years ago. And there was this one that stood out in particular called Space Got Mad, which is kind of a meteor defense game. Kind of a meteor defense style game where you click with a crosshair and it fires rockets up at meteors. I thought to myself that it'd be a good candidate to port to my latest engine, the engine that I now call the Rebound engine. So I really like the look of it, and I would really like it to be building for the web so that you can have it in a web browser, and my engine does that. What I'm going to do is go through the progress that I've made as I go along. You're probably going to see my clothes are going to change a few times. I'm probably going to be in various different moods, and my hair's going to grow or shrink. And that's because it's going to be several days of recording, so I can't promise any continuity. I'm fairly confident this will be successful though. Let's get started. So this is what I'm going to port to my new engine. I'll just run the old version of the game. So you can see it's using text rendering and it's rendering some images. Here it is. Basically you just click and you try and score the highest score before your base gets destroyed by meteors. That's pretty much all we got there. So I want to port this to my new engine so that I can play it in a web browser. And what I've done to achieve this is I've taken my Rebound engine code, I've taken all of the Rebound specific stuff out of the states. So the way my engine works is basically have a code in my engine that controls the various states that the user is at in the engine. For example, like the main menu or the main play area or the game over state. So I have classes that represent all those things. So all I've done is I've stripped out all of the logic that's related to the Rebound game, and also I'm in the process of swapping out the assets in the Rebound game with the assets that are in the Space Got Mad game. So this is what I've ended up with. So we have our constructor, very simple. And again, I've got a destructor just to clean everything up once we're done with that state. As you can see here, we get a point to the window, and we get all the events and all the event queue. And here we have a few sort of general purpose events that I will need for the game. So we have events like SDL quit, which gets fired when the user tries to cross out of the window. We've got a check for the return key to start the game from the main menu. Also the mouse button equivalent of that to initiate the game, and then a key down to check for escape if you want to completely close the window. We have update logic, which is usually where all of the logic gets updated. It's where you're going to do things like check if a player is colliding with something, or if certain criteria has been met to win the game or lose the game. It's kind of like the game's heartbeat of like the logic heartbeat. Just updates the state of the game based on other things that are happening. And then we've got the paint function, and this will just draw everything in the order that you add everything to here. As you can see, we're getting a reference to the window, and then we're drawing the title screen to the window. We also have another function to set up. This is slightly different to the constructor. This gets called from my engine just before the state is on has been run for the first time, and this is usually where we load assets up. So as you can see here, we're loading some assets up. We've got the start screen. We also have end state as well, where this is where things get cleaned up before we advance to the next state. And again, the start state, it's just this would be called if you went between a state and then back to it. It would call this one multiple times, whereas init state only gets called once. Exit state is just again more cleanup. It's less final than end state. Sort of end state and init state are kind of should run once during the life cycle of the states. An exit state again is kind of run each time the user exits the state. Doesn't matter how many times they've been in the state. Pause state is self-explanatory. It just pauses the game. Resume state, again, it just takes it out of the pause state. And then I have a bunch of things where we can pass values, different states. So that's the main menu state. It's much the same for the main gameplay area as well. I've just loaded a different background in, and there's just a few more things going on here. For example, I've just added a key command so that I can go straight to the game over state. Went ahead and built that, and I've swapped some of the assets over, and this is what I've got at the moment. So this is the game in debug mode. I currently can't do text rendering in this engine. It is supported by SDL TTF, but I haven't actually brought that functionality in my engine yet, so I need to replace that. SFML used to give you text out the box. I just need to write a wrapper in my engine that wraps SDL TTF. So if I go ahead and click here, as you can see here, we've transitioned to the main gameplay area, which is just a PNG of the moon. And you can see the green and blue earth in the background. As there's no win or lose conditions yet, if I've just, that's for debug, if I hit the G key, it brings you to the game over state. So, and then I clicked again, it's brought us back in. If I hit escape, it will end the game. I've got the basics of the engine laid out that I can port from my old version to the new version. So hopefully I'll make some progress soon with that. But as you can see, it's just early days. So I will update you in the next one. There again, I made a little bit of progress, so I thought I'd do a quick update. I'm now just testing the web build after I've ported some features of the old game into the new game. So I'm just running the build here in the browser, and as you can see, it's got those buttons from the last video that we had there. My eventual aim is to have some kind of standardized control panel thing to share between all the games, like a standardized web game container. But for now, as you can see here, I've added the start button. It was in the old version of the game. That now works again. We'll go ahead and click that. We go back to the main level. But the main take home here is that I didn't have to really change any code to get this web build to work. Like, I'm just getting this for free, which is amazing. I'm just pulling in the functionality from the really old version of the engine and just updating everything, and it's going really well. So, so hopefully I'll have a game to show you by the end of this. In terms of the code I've ported over, really all I had to do was add a new sprite, there's a start button, and then just add the constructor and destructor for this. So just delete it when it's finished. Obviously set it to null so that it's not a dangling pointer at any point. So I've added a mouse button down event using SDL's mouse button down, and I've just added a check for collision with the button. So if the mouse button's down, as in someone's clicked a button and they're hovering over the button, then progress to the next screen. I've also got an event for mouse motion, and that activates the logic to show that the button's been hovered over. The color of the sprite changes slightly. I implemented this using sprites, so it's just a lighter color and a darker color on one sprite sheet, and we just move that up and down based on whether the cursor's over the button or not. And aside from that, we just paint the button to the screen. And finally, just to initiate the state, I've just added call to my image resource manager to load in start button from the new assets directory. This is different to the original assets directory because I only had to handle desktop builds, but with Emscripten, what it does is it relies on the fact that there's like a directory that it can see, and it then bundles everything in that directory, everything like assets and sounds and everything. It bundles it into data files, so it needs to be in a certain place in the project. And then once that's done, we just create a sprite from it, and we set the animation to the first cycle, and that just shows the unselected state. So not too much to it really. So it's a different evening, but I've made a little bit more progress. We just run the debug version of the game. You can see here that we've got the start button working, and if we go and click here, got the crosshair drawing, just like the mouse cursor, hiding the mouse cursor. And we're drawing the buildings across the ground here, so a little bit of progress, just moving everything over gradually. In terms of the work carried out, I had to migrate over a couple of classes. There's the target class, which holds state about the health of something and the score bounty. And also I had to get the building class, which represents the buildings and also inherits the target. So yeah, all those attributes. So just going to keep making progress. Hello again, it's yet another evening and I've made a little bit more progress. What I've been doing is I've been trying to get the meteors to spawn and to move towards the ground in the game. And I have managed to do that. Is the game running? And you can see that every second or so a meteor appears and it falls down in a random position. Now, I had a little bit of a snag with this because in my original version of the engine it was using SFML, and SFML provided a vector class. But moving to SDL, there is no class for that, so I had to write my own. It's pretty simple. We just go to vector2f. As you can see, it really is just kind of a holding place for an x and y value. But moving to SDL, there is no class for that, so I had to write my own. It's pretty simple. It really is just kind of a holding place for an x and y value. We also calculate a magnitude as well, but that's not included in the vector. So what I do is when I create a meteor, I dispatch it, and what I've done is I've determined sort of the starting position and the end position. And then what I do is I set that initial position, and then what I want to do is calculate how to get from that starting position to that end position. So what I do is I take the two vectors and I subtract the from position and the to position to get the difference vector. Calculate the distance. I'm trying to get a unit vector, which is a vector with a magnitude of 1. If I understand that correctly. It's been a long time since I wrote this. So the way I do that is I take my difference vector and get the square root of x times x plus y times y of the vector. What I do is I then divide the vector by the distance. Yeah, so I take the vector, the difference vector, divide it by the distance. Hey everyone, it's now Saturday afternoon and I wanted to just do a quick progress update. I have been working away this morning on getting text to show in the game. You'll see here that I've in fact got text running. The title here is a TTF rendered font. I've written a text and a font class to wrap the SDL TTF library and make it work a little bit like the old library which I was using, which was SFML's built-in text and font features. So we've got render text there, and then now we also have the score being recorded. I also ported over all of the logic to track the user's score, and also now difficulty of the game will ramp up as you hit certain milestones. So, you know, it's like hundreds of points, 500 points, 1,000 points. Essentially, the game gets more difficult as you increase your score. So you can see that the meteors are sort of increasing in quantity and are appearing at shorter intervals. So that's great. It's pretty much a finished game now. So if we go to the game over screen, that's all working. And we start again. What I need to do is I need to add to the state transition. Yeah, I need it to re-render the score back to 0. But apart from that, everything's pretty much ported over to the new engine. So what do I need to do to get to this? As I said, I wrote a font class which takes the calls and wraps them into a C++ class. So what I can do is have a constructor, destructor to close the font when the object's been deleted, and I can load the font using SDL TTF. I can also return the raw font which the text class uses to render the font. So if you go to the text, the implementation for the text class, essentially you set an initial width, height, X and Y position, but also a font and a rendered texture. What this does is takes in the has a setter for the font that you've created using my font class, positions, the color of the text that's going to be shown, but then also just the string that we want to show as text, and also we need to store the renderer, the window renderer, which is the SDL renderer, in order to draw it to the screen. In our render function here, what we do is we check to see whether there's any textures existing already, and if there is, then we destroy the texture. It's no longer, it's an invalid texture, so we want to invalidate it and clear it out. We want to take an SDL surface and render our font to a surface. Taking in text that we provided and the color. After that, we want to create a texture from that surface, and then we want to free that surface up. And then finally, when we get to the drawing phase, what we're going to do is we're going to let our window draw the resulting texture that we rendered earlier on to the screen. So it's just putting it in position on the screen based on the coordinates and dimensions we provided. So pretty simple, really. Let's take a look at how that's used in the game. We'll be able to see here that we have title text and title font. And what we do in the init, we create a new font object. We also create a new text object. And then for that font object, we load in a font file, which is in my assets directory, assets fonts, which is just Arial. Let's give it a size. And then for the text, we create the new text object. And for that, we need to set a renderer. We need to set colors using RGB. We need to set the text string and set the font by passing in our title font that we've created there. We then want to say where we would like to show it on the screen. And then we call the render function. Now, in this case, because this is the main menu, we're only ever going to show one title. It doesn't need to move. It doesn't need to change the text. Doesn't need to change the color. Size doesn't need to change. So I'm just calling render once when we start up the game state. And then what I'm going to do in the paint function, the paint method, is I'm going to just draw it at every frame. So just like everything else. And that means that the title is printed at every frame, every refresh of the screen. Contrast that with when we use it in the play area state. What we do is we go through the same process of setting up the font and then building, instead of making a static string to show on the screen, we use a string stream, and we use that so that we can take the integer value score and feed it into the string stream, turn it into a string, and then use that, build that string up to set that value in the rendered text. So we do all the same setup here. We call an initial render, but then instead of calling render once, what we want to do is call a render after each time that the score changes. So as you can see here, we've had an added score here as a result of some kind of a collision between bullet, a player's projectile, and a meteor. It's adding the score, and then with a given bounty, and then what we're doing is we're then displaying that score again. So only then do we then want to re-render the texture. This is performant. It's sort of, you know, it saves resources. Only rendering the texture when we need to. We absolutely have to draw the texture each frame, but we don't have to re-render the texture from a surface. So that's what we're doing here. And then again, in the paint method, we're just drawing the score as the thing at the top of the screen, the last thing that gets rendered, so it's on top of everything else, and that's all there is to it, really. So I wanted to offer a little bit of a retrospective on working on this project, porting it from my old game engine to my new game engine over a few days. I would say that it was a really fun project to do. It was really cool taking something that I wrote now going on about 11 years ago and getting it to work in my modern engine. There were some challenges that I had to overcome, like for example that I didn't have any way to render text in the engine, so I had to build out some text and font classes to wrap that functionality. I came across a bunch of trigonometry that I did and vectors that I used that I wrote years ago, most likely a kind of a hodgepodge of stuff that I learned from Stack Overflow and experimentation, stuff that I've long forgotten that I had to port over to the new engine. One thing that I found, which I have no idea why, is when I'm calculating the angle for firing the sort of the angle of the rotation of the bullets that get fired from the player's silo to the meteors wherever they clicked. I had to invert the angle that I got from that because it kept giving me the kind of the negative version of it. So let's say I wanted to fire a bullet and I wanted the sprite to be rotated 45 degrees so that it fires up like that. It was giving me like the opposite of that. It was like negative 45. I have no idea why. I don't know what's changed in the engine, except for the fact that I was relying on built-in vector class that SFML provided, and I had to write my own version. Still don't know exactly why I have to invert the angles, but inverting the angles seemed to just fix it. So that's one of the things I found challenging, debugging that, figuring that out. Main thing I've learned from this is that this engine has lots of awesome functionality. It was actually quite easy to develop in it, but also there's things that I obviously didn't think about when I wrote the engine, so there's plenty more to improve and add on and just keep going with it. Another thing that I'm a lot more sure of now is that I'm able to deploy games to the web using this engine. I had to do barely any web browser specific stuff to get this to work in a web browser. All I had to do was update the makefile, really. It's great. It's fully abstracted from the idea of it needing to build for the web. It just kind of works, which is a great place to be in, because now it means that I can develop games with this engine that work on the desktop, they work in a web browser on a desktop, work on a tablet, and I'm just getting that functionality for free now, so that's amazing. So yeah, hopefully this was a fun watch. I kind of clobbered it together from the different days of footage, so hopefully it's come out good and it's been entertaining. So I implore you to stay tuned. Please subscribe if you would like to. That way you won't miss the next video. And with all that said, thanks for watching, and I'll catch you in the next one.